We're now going to be looking at a word problem that's part of a category of rate and distance. And whenever you work with problems like this, you have to know the following two equations. One is, or not necessarily two equations per se, but methodologies on how to solve these kinds of problems. So one of them is distance 1 equals distance 2. That's a concept you use when both people or objects involved in the problem travel the same distance. And I think in this case that may work for this problem, because let's read the problem and see if that works. Sammy leaves town driving 40 miles per hour. 2 hours later, Carol leaves from the same place, traveling the same road. She catches Sammy after 5 hours and 20 minutes. How fast was Carol driving? Sometimes if you make a diagram on a problem like this, it makes the problem a whole lot easier. So let's try to do that. Let's take what we see here and put it in a diagram. So they both start from the same place. And when Carol catches up to Sammy, they're also at the same place. So let's talk about that as being the start and the finish. Now, it turns out that Sammy does leave 2 hours earlier. So let's say here's Sammy's car. And Sammy travels at 40 miles per hour. And after 5 hours and 20 minutes, Sammy ends up over there. So 2 hours later, Carol takes off in her car. She drives faster, obviously, otherwise she couldn't catch Sammy. But we don't know how fast, so let x represent the speed at which Carol travels. And after a total of 5 hours and 20 minutes after Sammy left, Carol also arrives at the same spot. So you can see that in this case, both of them drive the same amount of distance. However, Carol drives faster and takes less time to get there. So that's why this equation here, this approach of solving the problem really works. They both travel the same distance. So we can write distance 1 equals distance 2. So distance 1, let's say that's for Sammy, and distance 2 is for Carol. And since they travel the same distance, you can say distance 1 equals distance 2. Now we're going to replace each distance by what they're equal to. Distance is defined by the rate times the time. So that means the rate of Sammy times the time that Sammy travels that distance equals the rate of Carol, that would be 2, times the time that Carol travels that distance. Okay, now we can plug in what we know. The rate of Sammy is 40 miles per hour. And the time that Sammy takes, she takes the full 5 hours and 20 minutes. Now 20 minutes is 1/3 of an hour, so we can write 5 1/3 hours. Equals the rate of Carol, since we don't know what that rate is, we'll write x. And the time that Carol drives, well, she leaves 2 hours later, so she travels 2 hours less. So it's 5 1/3 minus 2, that gives me 3 1/3 hours. And if I solve that equation for x, that will let me know how fast Carol was traveling. Okay, the first thing I want to do is convert these into what we call improper fractions. So I'm going to write 5 1/3 as, well, if I multiply 5 times 3, I get 15, plus 1 is 16. I can write this as 16 over thirds equals x times, and 3 1/3, 3 times 3 is 9, plus 1 is 10, times 10 over 3. So I converted from a mixed number to an improper fraction. Now I can go ahead and get rid of the fractions by multiplying both sides by the lowest common denominator. In this case, that is 3. So multiply the left side by 3 and the right side by 3. So 3 times 16 thirds, that's the 3's cancel out, and end with 40 times 16 equals, and 3 times 10 thirds, the 3's cancel out here, I get x times 10. Of course, that's the same as 10x. I can switch the 2 around, so I can now write 10x is equal to 40 times 16. And since I'm running out of room here, I'm going to scoot right over to the other side of the board, right there. I can multiply 40 times 16. 4 times 6 is 24. That's 640. So 10x is equal to 640. And now I can go ahead and divide both sides by 10. That cancels this, and I get x equals 64. So 64 is the rate at which Carol travels. Now, to make sure we did this correctly, is there some way we can check? Well, if Sammy travels 40 miles per hour for 5 hours and a third, then I can calculate how far Sammy travels. So distance 1 for Sammy is equal to the distance equals rate times time. So the rate is 40 times the time, which is 5 and a third. So 40 times 5, that's 200. Plus 40 times a third, that's 40 divided by 3. And 3 goes into 40, 13 and a third times. So that would be 213 miles and a third. Okay? We'll do the same for Carol. Distance 2 for Carol. So she travels faster at 64 miles per hour, and she travels for 3 hours and a third. So 3 and a third. So 3 times 64, that's 180, that's 192. And 64 times a third, that's 64 divided by 3. And 3 goes into 64 21 and a third times. So I add that there, I get 213 and a third. They're both the same. That means I did the problem correctly. So that's how you solve a problem using distance, rate, and time.